Welcome back to the main stage. Up next, we're excited to welcome James Cowling, CTO and co-founder at Convex, to talk with us about how backends should be designed for front-end developers. James, welcome to the main stage and take it away.
Thank you, Aaron. Hey, everyone. So I'm an infrastructure guy, but I want to talk about why infra, I think, is letting down product developers. And my background's in large-scale distributed systems, and my co-founders and I designed and built a lot of the big infrastructure at Dropbox, stuff like multi-petabyte or multi-exabyte distributed storage systems comprising 1 million disks across half a dozen data centers, or multi-petabyte distributed databases that serve like literally millions of fully consistent transactional queries per second. And now I'm a co-founder at Convex, which is a backend as a service that synthesizes everything we've learned about systems into a platform for building applications. So it's the database, the compute, the scheduling, the data sync, the storage, everything you need as the backend for product development. But Convex is a very opinionated platform, and it's designed with some strong principles that I think lead to a surprisingly good developer experience when building full stack applications. And when writing this talk, I was thinking back to the origin of some of these ideas and my time doing a PhD with a professor named Barbara Liskov at MIT. So you might have heard of Barbara. She's one of the most important figures in computer science, and the Liskov substitution principle is named after her. But I think part of the reason she was so influential is she started in the early days of programming language theory and was actually the person who pioneered the idea of abstraction in programming languages and then moved into systems, so distributed transactions and consensus protocols. And I think the programming language world has a lot of really important lessons that can be applied to how we think about backends and how they're used by product developers. So this won't actually be a deeply theoretical talk at all. It's actually going to be a little bit of a provocative talk. And I really want to talk about how backends should look to better serve full stack developers. And the reason I'm giving this talk is because of a crisis we have on our hands. It's a new crisis, and I think it can be hard to recognize it if you don't know about the first crisis. So I'm going to go back to the software crisis, which was a real thing. It was a huge topic of concern back in the late 60s and the early 70s. And you can go read about it on Wikipedia. But the essence of it was that as technology improved, productivity actually slowed down. It became harder to write programs. And this is Dijkstra talking about this. He was a famously smart dude. And he said that when we had a few weak computers, programming became a mild problem. And now we have gigantic computers. Programming has become an equally gigantic problem. Now, obviously, computers today are a lot more gigantic than they were back in 1972. But this was him observing that the industry was grinding to a halt. It was getting harder to write programs. So why was this really smart person in 1972 saying, hey, we're kind of grinding to a halt and things are kind of largely okay right now? I think the reason you don't hear about the software crisis anymore was that it was largely solved, or at least ameliorated, by this thing called abstraction, a really, really important thing. So once upon a time, there was just shared memory and go-to statements and global variables, and any new feature added to a program also added to the cognitive overhead of maintaining a program. But then we added information hiding and modules and functions and abstract data types. And all of a sudden, everything became a lot more tractable. And the real key convention here that resonates for me is that for well-designed software, your relationship with a library or a system ends at its API. You don't need to know how it's implemented. You don't need to know what downstream libraries or systems it uses. And you don't need to know about situations where it doesn't do what it's meant to do. You just interact with the invariant specified by the function, and that's the end of the story. So this is how we stand on the shoulders of library and systems builders rather than being burdened by them. And it's really the only way to build large systems, large products, and large organizations. So why does this matter to you? I think we have a similar crisis on our hands, a platform crisis. And this is just a phrase I made up just now, but the landscape for developing applications, in my opinion, is a horrendous mess. We have developers on day one of their application trying to learn how to administer Kubernetes, a technology that a decade ago was only the domain of multi-billion-dollar companies. Or reasoning about data freshness and the difference between data rendered statically on a server, even a server component, or dynamically on a client, or cached somewhere, or stored within an edge database. These are very complicated programs. complicated problems. And I'm hearing from product developers that are complaining that their relationship with the platforms that they use don't meet what I would call the abstraction test, right? So they have to think about a huge amount of complexity when using and interacting with their backends rather than just treating it like a function. And I think this is because platform developers have forgotten about the software crisis. They've forgotten the real value of abstraction, which is to make problems go away and reduce the number of moving parts a developer has to think about. So the issue here is that backends don't just feel like libraries. They feel like complicated, conditional, poorly composed sets of tools. So I'm going to outline 4 major bad ideas in the status quo of full stack development and how I think they can be rethought in a more principled fashion. And these are areas where backends can do better to provide a simple abstraction for application developers. So let's start with bad ideas in query models, how applications access the database, both in terms of exposing the database directly to clients, shout out Firebase right there, and declarative query languages like SQL, which I'm sure will ruffle a few feathers. So in an era before this serverless movement, where it wasn't so easy to have Lambda functions running in a cloud or an API server running somewhere, there was a movement towards getting rid of API servers altogether, where you'd have client JavaScript code talking directly to the database, just accessing documents in a table. And I have a lot of respect for Firebase for being a very pioneering platform with great developer experience in many ways. But I think this decision was a mistake. It was a mistake motivated by desire to make the database accessible to application developers in their native languages, whether that's mobile or web. But it has a great many disadvantages. It exposes your private data model directly to the client. It makes it hard to manage secrets or private code. It leads to thick clients which have a lot of logic in them. And then later on, complicated initiatives to try to speed up page load because of all that software sitting on the client. And it really erodes the concept of a transaction, where you want to do multiple separate things, talk to separate tables, but you want them all to happen once in a single transaction. That becomes much more difficult when the client's in the loop. So you force developers into a development model that's accessible, but it really makes life difficult later in the life cycle of a project, which is something we hear over and over again from developers on these platforms. It also gives birth to well-intentioned, but I think misguided initiatives, like encouraging developers to adopt row-level security really early in a project. I know many billion-dollar companies that don't allow row-level security in the databases or don't enforce row-level security in the databases because it can get horrendously complicated. And generally, it's a lot easier just to perform access control checks on the server, which you can't do when the client's talking directly to your database. And now I'm going to commit sacrilege and say that SQL sucks today. So the people who invented SQL are very smart. Definitely smart. And I say this as someone who's managed literally tens of thousands of SQL servers before. And I like SQL as an analytics query language. But for live, user-facing, low-latency transactional applications, SQL, to a large extent, is somewhat of a successful abomination. Almost no company runs handwritten SQL statements in the live path of their core services. The query language is too brittle and inexpressive. The query plan is unpredictable and will suddenly do something like performing a full table scan without you expecting it. And even if you passionately disagree with my point here, I think you probably secretly agree because you're probably using an ORM to hide SQL, except that this ORM is only providing the illusion of guarantees, which I'll get to a little bit later on. So I'd like to instead present what I think is the right idea for how to run a database in the modern age, or database queries in the modern age. And that's just to run code inside your database. This is not just stored procedures. I'm talking about real TypeScript functions that run in transactions directly inside your database. So this is a mutation in Convex. It's just a program. It runs as a strongly consistent ACID transaction. You write this code alongside your web app, you push it to the server, and then you can just call it from client code, just like an API. It can access secrets. It can talk to other functions and invokes functions like features like scheduling or storage. But critically, it's a transaction. It runs as a single atomic unit. You don't have to think about race conditions. And if it fails, it'll get retried. So there's no need to compromise on expressivity here because it's literally just code. And you can go back to having platforms that actually function like libraries with clean abstractions. So I want to move to the next domain where I think platforms fail the abstraction test, which is their type system. And I have a lot of respect for MongoDB, for example, for making databases accessible to web developers. But the fact that Mongo is a largely untyped JSON document store means you have to give up on all the familiar programming language guarantees you're used to. So there's a reason why everyone's moving to TypeScript from JavaScript. Types are good. They provide actual guarantees. And while I've criticized SQL, the relational model is also an incredible idea. Data is often related to each other, and the references between these items of data need to be typed too. And I probably don't need to convince you that manually formatting SQL strings is a terrible idea and has led to an enormous number of bugs and vulnerabilities, including SQL injection attacks. Stuff like where you set your email address in a form to semicolon drop table users or whatever, and the entire users table gets dropped. This is the canonical argument in favor of type safety in query languages. But to be a bit more controversial, I think ORMs are a leaky abstraction too, because they provide the illusion of type safety and a convenient API, but they're really slapped on top of a database like Postgres that provides neither of these things. They give the illusion of safety, but don't actually represent the semantics of the database. So this includes old ORMs like SQL Alchemy that I've used personally a lot and I've witnessed many bugs being written in. But it's even with way, way better ORMs like Prisma, which is really quite good in many ways, but it's just a layer on top of someone else's database at the end of the day. There's no true end-to-end type safety between what the developer's writing and the client application and what's actually getting read or written from the database. So the holy grail is true end-to-end type safety, where the types the application developer uses are literally the types of the data that resides within the database, where there's autocomplete for everything, even for the names of the tables in the database. This is how things work in Convex. The queries are TypeScript and they map directly to Convex types. There's autocomplete and type safety. And you can see here in this animation that you can kind of iterate your way to success without worrying about bugs showing up. So here the database and the query model are designed together. So you can just think about it like programming. But you might ask that if type safety is so important, why are document stores like MongoDB and Firebase so popular? Well, they're popular because they're convenient. They're popular because they don't force you to write a schema definition for a program you haven't even written yet and haven't even decided how to model, right? This is a screenshot of some, SQL schema definition here with all the complexity that it comes with. So this is a development velocity issue, and it's an important one, which I'll capture as a bad idea on its own. And that bad idea is premature formalism. Because none of this matters if you can't move fast and develop your application to begin with. Fortunately, we can have our cake and eat it too, because Convex will automatically infer the schema for your application purely based on the data that's been inserted into the database. So you can start off just treating it like a JSON document store like Mongo, and it'll let you incrementally enforce schema on your schedule when it makes sense to do so. Type inference in Convex works in real time, and it uses an algorithm that computes the simplest possible type based on the data in the table. So if you insert a string into a field, the schema will be string. And if you then insert a floating point number into that same column, the schema will be string union float. And then if you go delete that original string row, the schema will revert to float to be the simpler type. So this happens automatically and precisely without slowing down the database. But what can you do with this? Well, you can then go and enforce that schema when needed, when you want that type safety. So this is a screenshot from the Convex dashboard for one of my applications, showing code that we can copy and paste into our application and have end-to-end type safety for these two tables called items and carts. And you can see, by the way, there's a typed reference here from an index, from an item in a cart to info about that item. So there's type safety even for references between these tables. End-to-end typing allows you to forget about talking to tables that don't exist or data that doesn't match a schema, and it allows you to develop as quickly as you would with a regular TypeScript app, because that's what it is. It's a regular TypeScript application. So we'll move from the query model to systems concerns. And I think this is a really big one that's actively getting worse as we speak. Many of these things are getting better every day, but I think this issue is getting worse. Latency matters for your application, of course. But latency is higher, by the way, if you have multiple rounds of communication between your client app and the database, because you can't run functions on your database. But latency and throughput are an issue nonetheless. And caching is a main technique for dealing with this. But it doesn't matter if you're running a consistent database in serializable mode, if you're just slapping memcache in front of it, and now you have to reason about your reads getting stale. For example, a situation where you insert a new row in a database and you want that row to show up in the results of your application, you have to now go and manually invalidate that cache or decide that you're okay showing stale results, which leads to a huge amount of complexity in a lot of applications. And there's this recent movement now about the edge. So the edge, by the way, just means putting servers and databases in secondary data centers close to your users for latency purposes. But now you have to deal with one of the hardest problems in computer science, which is cache consistency and distributed data sync. And I find it amazing that we're recommending to developers to be thinking about these techniques early on in their application when they want to be focusing on building apps in the simplest possible way. So what's the better way? I think the better way is dynamic, consistent caching. If a database knows every function that's run on it, and it knows all the data ranges that are read in every query, and it knows every write that happens, then it can automatically cache the results of every function completely consistently and automatically. You shouldn't have to be doing this manually. The system should do it for you, which is what Convex does. Every function in Convex is cached automatically, and we record for every function every data range that was read. And then if any new write overlaps with any of these ranges, we know to refresh the value in the cache. This can happen at the back end, but by the way, this can also happen at the edge. So I actually am a fan of the edge. I think the edge is great. I just think developers shouldn't have to know it exists, right? They should just use the back end. The back end should deal with these problems, and it should be fast, and that's it. That's the end of the story. So again, don't make developers think about things they don't have to think about. Use abstraction to hide complexity. But somewhat related to caching is what to do when data changes. And there's actually a bit of a movement towards statically generated content again these days with stuff like server components in React. And a lot of people are talking about how we're kind of going back to PHP all over again. And I don't think that's necessarily a good thing. Generally, you want your apps to be dynamic. You want them to update when data changes. But generally, you have to use polling to do this, periodically checking the server to do so, which is hard and it's inefficient and it leads to stale results. And so you'll likely end up with some form of weak or eventual consistency. And as I mentioned before, it doesn't matter how consistent and transactional and ASIC compliant your database is, if that consistency is violated as soon as a client has to actually read from the database, right? For almost all backends that exist right now, the consistency boundary ends at the database itself. But I think the consistency boundary should extend all the way to the client application. The client should have a fully consistent view of the data that's stored on the backend and not see stale state. So let's talk about it. Earlier, I said that Convex knows when a function is cacheable, and it knows when the result of that function changes. It can do this very efficiently. So this same technique can be used to drive subscriptions. Every query in Convex can be subscribed to and used to automatically re-render your client components whenever data changes. So this is a screenshot of a little demo app I made a while back. It's just a little basic shopping cart demo with a dynamic list of items on the left and a dynamic shopping cart on the right. If you add an item to the shopping cart, the total in stock goes down, the prices update. It's a simple app, but one that's actually quite tricky to implement most of the time. In Convex, this is the actual query that fetches the list of items of the database. This is the thing that gets subscribed to. And the operative code here is mostly one line of code. This is line 8, where it says, give me the list of items in the database that have remaining stock. That's the end of the query. And this is the real React component that renders the dynamic items list. And this is the real code. You can go search on this in GitHub. I've got the link down there in the bottom right. And again, the main line of code here is really just line 6. It says, take the query that gives me the shopping cart items, store it in the state variable called items, and then anytime that state variable changes, React will automatically re-render that component. But you might say, wait a second, James, there's two components on the screen here. There's a cart and a stock list. And those two separate components have two separate queries and two separate subscriptions. So what if one updates before the other? This is the web, right? Stuff happens asynchronously. So the developer is going to have to think about a whole bunch of corner cases when one updates before the other, and what if an item shows up in stock when it's not really there? I think the platform should take care of this for you too. So Convex supports something called consistent client views. The platform knows you have two active subscriptions for a given client session. This ensures that they all update in lockstep. It always sends updates to any subscriptions over a WebSocket in a fully consistent order. So React will just update both of these atomically. You'll never see a situation where one component updates before the other. And this is true end-to-end consistency. And it's there so developers don't have to think about stuff. They can just focus on building applications. Don't think about data races, just think about calling functions. This has been a fairly rushed talk with a lot of content, but I really believe that developers have been let down by backend platforms. And I think we have a crisis of complexity on our hands. But the solution to this is abstractions that hide complexity at all times so the developer never has to think about this. With the right abstractions, I think developers can build apps that are faster to build, faster to operate, more correct, scale larger, are dynamic instead of static, and they can do this without a back-end team. I think by doing this, they can avoid the platform crisis and focus on what makes their app special, which is the app itself. None of this is hypothetical. It all exists, and you can go check it out at convex.dev.